Okay, let's continue with question 20. Question 20, we are going to use a graphical approach. So what I've written here is that the true temperature will be written on top, and the reading from the 40 thermometer will be written below. So for example, if the 40 thermometer reads 10 degrees C, actually it means that the true temperature is 0 degrees C. So what we need to know is, find out is that every increment on the 40 reading actually represent a temperature change of how many degrees C. So you see here from 10 degrees C to 90 degrees C, actually there are how many incrementation? Let's see here. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So there is 1, 2, 3, 4, 5, 6, 7, 8. So 8 units of incrementation actually represents a true temperature change from 0 to 100 degrees C. So this 8 unit of incrementation represents a change of 100 degrees C. So if we want to find out 40 degrees C reading corresponds to how much temperature change, we look at the reading here. So 10 degrees C, 20, 30, 40. So there are actually 1, 2, 3 units of increment. So using ratio, 8 units is 100 degrees C, so 3 units is how much? So you just take 100 divided by 8 multiplied by 3. So you will get 100 divided by 8 multiplied by 3. You will get 37.5 degrees C. So this reading of 40 degrees C actually represents a true temperature reading of 37.5. Interesting question. Okay, in the process of convection, energy is transferred. Convection cannot happen in solid, so B is out. Diffusion occur when there's a change, when there's a difference in terms of density. So that is not what we are talking about. Vibration of molecule about a mean position. This is actually the description for conduction. So this is wrong. So what actually happened is that in convection, of course, the temperature difference will cause a change in density. So because of this change in density, warmer fluid rise and cooler fluid sinks. So your answer is A. Okay, for your question 22, certain physical characteristic of a polar bear help it to reduce heat loss in winter. So okay, white coat reduce heat loss through radiation. That is true. A layer of fat under its skin reduce heat loss through conduction. True. A thick fur reduce heat loss through convection. Also true. So through convection. Convection is not true. The thick fur actually traps air, and air is a good insulator. That's why it reduces heat loss. And so although the fur does reduce heat loss, but it is not through convection. So answer is A. Question 23. Thermal energy is supplied at the same rate to 100 gram of oil, 100 gram of water. Container is the same, so don't consider container. What does the temperature of the oil? Why does the temperature of the oil rises more quickly? Definitely that is because oil has a smaller specific heat capacity. It is not due to density, so C and D is out. Smaller specific heat capacity means that you need less energy to cause a change in temperature. Okay, so having smaller means that you require less energy to increase the temperature. So definitely a B. Okay, 24. Diagram shows cross-section of a series of waves on water, which dotted line shows the position of still water. So you can see that A is the peak and C is the lowest point. So the mean water level will be B. Okay. Waves travel more slowly on the surface of water when the water is shallow. Okay, girl make an oscillatory motion by dropping her finger up and down at X. The diagram shows the wavefront on the surface of the pool. Which region of the pool is likely to be most shallow? Okay, because the frequency is generated by the finger dipping up and down, so frequency in this whole system will be constant. Yeah, and you know that wavelength can change because the velocity of the wave is affected by how shallow or deep the pool is. So you know that V equals to F lambda, and you want to find which region is the shallow one. And on top here the statement says that the water actually travel slowly when the water is shallow. So what you're looking for is the minimum velocity. So if you want to find a minimum velocity, basically you have to find the minimum wavelength. These lines are actually the wavefront. So the definition of wavelength is the distance between two wavefront. So if you look at this, you can see that okay, it means that this is one wavelength. Okay, so you need to look for the minimum wavelength, and so definitely is your A. Okay, question 26, blah 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 blah, in all correct order and all this. This one refer to your book, okay? Now, when you look at this question, it may seem to you that it is a diverging lens, but you need to check first whether a virtual image is formed or not. Okay, because when a virtual image is formed, you are going to see the actual light ray being diverged like this. So let's check first. So if you extend the ray backwards, we have to check whether these two rays actually converge or not. You see that, oh, it did. It converged. So what happened is that when this happens, a virtual image is going to form because the light ray is going to converge at one point. The virtual light ray is going to converge at one point. So it means that it is going to have a virtual image, and for a virtual image to form, it means that your focal length must be somewhere here. Okay, for a virtual image to form, the object will be in front of 1f. So you know that this lens, it is converging, and your focal length is going to be more than 15. Okay, so it's going to be more than 15. So your answer is A. Question 28. Okay, question 28. Okay, the diagram below shows two notes, P and Q, produced by two different instruments. Okay, which one of the following statement about P and Q is correct? So the higher the frequency, the higher the pitch. P definitely has a higher frequency because it forms more wave within the same time. So P definitely have a higher pitch. The amplitude determines the loudness. So you can see that P's amplitude is bigger than Q. So definitely P is louder than Q. So P is louder than Q. This is correct. And P is having a higher pitch. So your answer is D. Okay, question 29. Refractive index 1.78. Ray of light pass through piece of sapphire. Which of the following is the critical angle? Okay, question 29. Just use your critical angle formula. N equals to 1 over sine C. Remember to use degree mode. And it will be quite easy to solve. 1 divided by 1.78. Arc sine. And you will get the answer 34.18. So round it up, 34. So your answer is A. Okay, loudspeaker. Okay, loudspeaker emitting sound fixed intensity with travel equally in all distance. Pressure variation. Okay. Speed of sound is 333. Frequency emitted. So definition of frequency is frequency. Okay, what can we get from this graph? This graph just tell you pressure variation and distance. So in this graph, you cannot find the period. So what you can find is you can find the wavelength. So wavelength can be defined using pressure variation because the peak of the pressure point can be interpreted as the compression phase of the longitudinal wave. So when the pressure is at maximum, then definitely it represents compression. So you can see that the distance between two compression will give you the wavelength. So from here you can tell that the wavelength between this point and this point is 2 meter. Yeah, so you know that lambda is 2 meter and you know that your v is equals to f lambda. You were told the velocity is 333. So you can then find out what is your frequency. So you just take 333 divided by 2. You will get the answer 167. So this is your C. Okay, then question 31. Light bar magnet is suspended near a current carrying wire. What will happen to the light bar magnet? Okay, this one you need to use your right hand grip rule. When the current is flowing up this way, the magnetic flux line will follow the index finger. So it will go basically this way. So what happens is that your magnet light pole will repel. So definitely your magnet will rest somewhere like that, with the south here and the north here. So it kind of rotate clockwise. So that will be your A. Okay, question 32. Which diagram correctly illustrates the electrical field around positive charge? So positive charge definitely A, because it is stationary, right? It didn't say that. Okay, these two represent a wire, so that is not a point charge. This is a point charge. Okay, what will be voltmeter reading in this circuit? So, okay, this voltmeter is actually measuring the potential difference across the two resistors. So basically, this is a very simple circuit. You can simplify it by combining these two first. So you have your 12 volt going through your 1 ohm, and then these two is in series. This resistor, single path, so it's in series. So it becomes 4 ohm, and that is your circuit. So your voltmeter, you can treat it as invisible. So this voltmeter is actually measuring the potential difference for these two resistors. So basically you can just treat it as this way, and things will become much clearer, right? So series circuit, voltage is being shared. The ratio will be the higher the resistance, the more the potential difference. So total there are 5 ohm. So you just take 12 divided by 5. This one will receive more potential difference, so multiply by 4. So you will get 12 divided by 5 times 4. You will get 9.6. So this will be your answer C. Okay, for those who are weaker in your electricity, what you can think of is that this 12 volt is going to be shared by these two resistors. So these two resistors has a total resistance of 5 ohm. So that's why your 12 volt will be shared between this 5 ohm, and because this resistor is having 4 ohm. So out of this 5 part, this resistor took up 4 parts. So that's why the potential difference is 12 divided by 5 part and multiplied by 4. This is only applicable for series circuit. Okay, question 34. Okay, question 34, you were given 240 volt, 120 W as the power rating for the bulb. Now, a common mistake is that a lot of students will just simply plug in these two values and calculate the power dissipated. Now, the thing is, you do not know how much voltage the bulb is going to receive. This simply indicate the ideal operation parameter for the bulb. You do not know in the end whether the bulb is receiving 240 volt or not. And you also do not know whether the current going through the bulb is what. So you cannot simply plug these two values into your power formula. What you can find out from these two parameters is the resistance of the bulb, because the resistance of the bulb is independent of the circuit. So the first step is to use your P equals to V square over R, go and find out what is the resistance for the bulb. And then you know that the bulb is connected in series, so then you can work out your total resistance is 960. Now down here, you need to assume that the power supply, the power supply is 240. But if not, you may have too many unknowns. So once you know that this bulb, because it's connected in series, is only going to receive 120 volt. Okay, so with this you can actually calculate this I. What is this I? So what is this I? What is this I? It's very simple. It's just your V equals to IR. Your V will be 240. Your I you do not know. You know your combined resistance is 960. So you can work out your I. So this one will be your 240 divided by 960. This will give you 0.25. So once you know this, you can then apply your P equals to VI on your light bulb. So on your light bulb, the potential difference across one is 120. The current flowing through is 0.25. You can quickly find out that this is just your 30 W. So your answer is A. Of course, there are other methods to do this question. Once you know that this is 120 V, you can use P equals to V square over R, and then you will still get back the same answer as 30 W. Okay? Okay, question 35. Okay, when you go into your question 35, it is best for you to write down everything in ratio first to help you understand the question. So the question tells you that X and Y is having the same length. So the only thing you need to think about is cross-sectional area. So before you go into that, let's write down the ratio. So I want you to just be looking at this. So you see that the resistance ratio is 4:1, meaning that since they are having the same length, the cross-sectional area of X must be smaller. Okay, because the resistance of a smaller cross-sectional area will have a higher resistance. So once you know that, you can tell that the cross-sectional area of Y will be 4 times of X. So with this information, you can eliminate option C and D. Okay. Now the tricky thing about this question is that the other two options is talking about diameter. Okay, so it's talking about diameter and not just the cross-sectional area. So you need to play around with the mathematics. So the cross-sectional area, assuming it is circular, will be A equals to pi r square, and the radius is actually the diameter divided by 2. So if you expand this function, you see that your area is actually proportional to d square. This means that if your diameter is increased by 2 times, okay, your area will be actually increased by 4 times, because this square, when you open this bracket, the 2 will be square and all that. So you can see that this KD square, this KD square, in the end you get 4A. Okay. So when you increase the diameter for 2 times, you are actually increasing the cross-sectional area by 4 times. Okay, what I'm doing here is that, can you see here is KD square, this is also KD square, so KD square equals to A, so I can put this as A. So you can see that by increasing the diameter by 2 times, this new area is actually equals to 4 times the old area. So that's why when we are looking at the diameter, okay, increment of 4 times in the cross-section area only required diameter change of 2 times. Okay, so that's why your answer is B. So this question required a bit of mathematics. Okay, you need to understand that when the diameter is increased by 2 times, the cross-section area is actually increased by 4 times. Now, if you are having difficulty understanding this, what I suggest to you is that just put some value inside. Go and try a diameter of 2 cm, calculate the area, and then try diameter of 4 cm and see how much the cross-section area increased. Okay? Okay, for your question 36, which of the following situation will a fuse possibly melt? Okay, earth wire is broken, it won't affect your current flow, so it will not melt your fuse. Short circuit, definitely, because of a large current surge. Fuse is fixed along a neutral wire instead of a live wire. The fuse, if you put it on neutral wire, it will not cause a large current surge. So nothing will happen, just that your circuit is not that safe. So your answer is B. Okay, question 37. X and Y positively charged sphere and have the same amount of electrical charge. So both of them are positive, huh? Okay, and positive test charge placed at point P, equal distance from X and Y. Okay, so this force, if we have to analyze it step by step. So first we look at this positive charge reacting with X. So when this positive charge reacts with X, the light charge repel, so there will be a force, okay, from X this way. And when we look at this positive charge with Y, there will be a repelling force from Y as well. So when you combine the force from Y with the force from X, you will get a net force upward. So this is your answer, A. Okay, question 38. Current flowing through a solenoid. Okay, how does the strength of the magnetic field at point X, Y, and Z compare? Okay, if you draw out the magnetic field, it will look something like this. You can also refer to your book. Okay, so use your right hand grip rule, it will look something like this.